Alright, moving right along to problem 7 in chapter 8. I'll give you a little bit to read it. Okay, good enough. So now, let me just draw a picture of it. Pen tools handy. So we got a pendulum-like device going, and it has a mass, and it also has an initial velocity going down, length. Whoa. It has an angle down to the vertical. And that's it for givens. L equals 2 meters. Mass equals 5 kilograms. Theta equals 30 degrees, and initial velocity equals 0 meters per second. Part A wants us to figure out how much work gravity does on the pendulum. So work due to gravity is mgh. But what is h? Well, if we draw a little line over here horizontally, h is actually this distance from here to here, vertically how much it drops. In doing so, of course, this whole length is L again, right? Because the length of this pendulum string is L. So in doing this, we're going to want to split up L here into a Y and a H part. That's one way of doing it anyway. So then we know that cosine of our angle equals adjacent Y over hypotenuse L. That's this triangle here. And so Y equals L cosine theta, which equals 2 cosine 30, which equals about 1.732 meters. So now H is going to equal L minus Y. Hopefully you can see that from the picture here. L is the whole thing. H is Y subtracted from L. So that's going to be 2 minus the 1.732, which equals 0.2679 meters. So work due to gravity is mgh, mass is 5. G is 9.8. And H is 0.2679. So this equals 13.13 joules. Now this is positive because we're looking for the work that gravity does on it. And so gravity is pulling down. Its displacement is down, same direction, positive work. Alright. Part B is asking for the change in gravitational potential energy of the Earth ball system. So that's going to be delta UG, which is UG final minus UG initial. And we're as low as, we're as low as we can go here in the final position, so we've lost all of our potential energy, so that's 0 joules minus And then this is essentially the work needed to go from here to here is 13, and so the initial potential here would have needed to have been 13 in order to go down to 0. And so it's negative 13.13 joules for part B. Part C, we need to find if the gravitational potential energy is taken to be 0 at the lowest point, which we just did, what's the value of the potential energy where the ball is released up here? Well, that's the 13.13 joules that we stuck in here. So that's straightforward. And D, do the magnitudes of the answers A through C increase, decrease, or remain the same if the angle is increased? They all will increase because they all depend on h, and if the angle increases, h increases. You should be able to see that if the pendulum started horizontally, h would equal L, right? Because it would drop the entire length of the string. Alright, that's it for number 7.